video we'll talk about central limit theorem. Now, what central limit theorem says? In a probability, in a statistics, we have a different probability distributions. It can look like this. It can be normal distribution. It can be exponential. It can be uniform. It can be skewed, and right skew, left skew. In different situation we have a different probabilities. So in a real world situation we have a different probabilities with the different scenarios. Let's take example here. I have let's take the example of a rolling a dice, right? When we roll a dice, now what is the probability of that it will appear on 1? What is the probability that 1 will be occurred on a dice? So it is 1/6 probability, right? It is a 1/6 probability. Then what is the probability that it will occur 2 on a dice? It is also 1/6, similar to the 3, 4, 5 and 6. Why? Because total numbers in a dice are 6. Now for each number there is a probability 1/6, right? 1/6. So if you can see, each has equal probability. This is kind of a scenario, right, where the probabilities of the each random variable is equal, right, uniform. So when we try to plot this probability with respect to this x, it will give kind of a uniformly distributed. It will be uniformly distributed. Why? Because the probability of each event is equal, right? The probability of each event is equal. The reason why it will give the shape or distribution like this. This is the kind of a scenario when we roll a dice, right? And there are different scenarios for the different probability distributions. Now what the central limit theorem says? Central limit theorem says if you have any kind of a probability which is a population distribution, there can be exponential, uniform, right skew or the left skew. If any kind of a distribution you have, and when you try to take samples, n number of samples, there can be 100, there can be 200, there can be 300, 30, 40, any number of samples if you take, right? And after taking the samples, I give the here examples represent the each sample is x1, capital X1, capital X2, capital X3. After taking the samples, we calculate their means. Yes. We take the samples and they calculate the means with x bar, x bar 2, x bar 3, x bar 3. We calculate the means of each sample, right? When we calculate the samples means, after calculating the means of each sample, when we try to plot this mean like this, we plot these probabilities, it gives the normal uniform distribution. When we try to plot this means of the samples which have been taken from this or this or this or this, any kind of population distribution can be. It can be beta, it can be binomial, it can be Poisson, right? So after taking the samples and their means, calculating the means, and we try to plot this on a here, so it will give it will be normally distributed. This is what central limit theorem says. What central limit theorem says, if you have a probability distribution, different probability distributions, right? From this probability distribution, if you take samples, after taking the samples, you calculate the mean. After calculating the means, if you try to plot this on a 2-dimension or like this on a graph, it will be normally distributed. This is what central limit theorem says. Now central limit theorem is used in a very in different fields. It has very wide applications. There are some examples I have given here, right, which is the real world examples. Now the central limit theorem says The central limit theorem says the if you calculate the mean of the populations, which is mu, it will be equal to sample mean. It is very difficult for in a real world situation to calculate the mean of the population. Very difficult. So, and here it is saying the central limit theorem states the sample mean is equal to the population mean. Now, how we can use this in a real world situation? Let's take examples. I have taken the examples of the agriculture. Right. In agriculture, there are agriculture scientists. They have introduced a new kind of fertilizer. They want to see, and they want to use in fields, in crops, to how much crops we can produce, for the new fertilizer, right? So what they have done, they have chosen 6 fields to use this fertilizer for the experiment. When they use this fertilizer in 6 fields, they have seen the wheat crops is producing in a pound is 500, 300. The average, when we calculate it gives almost 440 pounds. When the fields are producing 440 pounds of wheat using the new fertilizer. Now, when the central limit theorem says the population mean is equal to the sample mean, so from here the agriculture scientists can make a best guess if it gives the 440 pounds wheat using the 6 fields. It means samples, which are samples. So we can make a best guess that for the population, for the population, that it can produce almost kind of similar to this if we use this fertilizer. Another example is the biologists or scientists. They have to take examples of a plant. They want to see the height of a plant in inches, right? They use different plants, 5 plants, and they see the height of this such plants. They have calculated the mean sample mean. They have seen there is a 8.88 inches average height of these plants. From here they can make a best guess that the plants have a height is almost 8.8 inches, right? So this is the kind of a situation where we can it can also be used for the Uber company. It can be used for that they are introducing adding the new features, right? And new feature, they want to see the response of the customers. They have seen the samples. They have taken the samples, the customer response, right? When they see the response of the customer taking the samples after adding the new features in the Uber service, now from here they can make a best guess whether their customer are liking or not after seeing the response from the taking samples. So here that is how you can use the central limit theorem in a real world situation. That's all about this video.